A very good morning to Miss Song and our fellow classmates. We are
Galileo's Kids.
Let us tell you the story of Jupiter.
Long time ago, when the Earth was much younger than it is now, people often talk about this mighty planet in the sky called Jupiter. According to the records, early Roman astronomers named the object after their most powerful god, Jupiter, or Zeus in Greek mythology, which is known as the god of the sky and thunder. He was also known as the king of the gods and as the ruler of mankind, as he influenced the natural law and the order of cosmos. This character fits the characteristics of the planet in terms of size and its stormy nature. There are many interesting moons orbiting the planet, approximately 79 of them, and most of them are named after Jupiter's wives and lovers, such as Metis, Eurynome, Himalaya, and many more. However, the ones of most scientific interest are the first four moons discovered beyond Earth, the Galilean moons, Io, Europa, Ganymede, and Callisto. They were discovered in 1610 by Italian astronomer Galileo Galilei. Ganymede is the largest moon of Jupiter, which is also the largest moon in the solar system. Ganymede has three main layers. Firstly, a sphere of metallic iron at the core which generates magnetic field, surrounded by a mantle of rock and spherical icy shell at the outermost layer. Through Hubble Space Telescope, scientists have discovered the evidence of thin oxygen atmosphere in 1996. However, it is far too thin to support life. Callisto is the second largest moon in the Jupiter system and is nearly the size of Mercury. Callisto is a half rocky, half icy world. Its surface contains water ice, carbon dioxide ice, silicate dust, rock particles, and hydrocarbon compounds. Io is the innermost and the second smallest of the four Galilean moons. This moon is stretched by gravitational pull of Jupiter and other neighboring objects. This phenomenon causes tidal heating that activates volcanism. With it, Io has over than 400 active volcanoes on its surface, making it the most actively volcanic world in the entire solar system. The last of Galilean moon is Europa, the smallest and the second closest to Jupiter. Europa is known for having a global ocean. It is hypothesized that the phenomenon of tidal heating is what keeping Europa's interior ocean fluid. Because the moon is water-rich and has warm interior, scientists think it could be hospitable to life.
Ten facts about Jupiter. Jupiter is the largest planet in the solar system. Jupiter was named after the king of the gods in Roman mythology, Zeus. Jupiter is the most massive planet in our solar system. Jupiter also the fourth brightest object viewed from Earth after the Sun, the Moon, and Venus. It has been known as a bright wandering star. Jupiter spins faster than any other planet. It takes under 10 hours to complete a turn on its axis, compared with 24 hours for Earth. Jupiter is about 75% of hydrogen and 24% of helium, with traces of methane, water, ammonia, and rock. This is very close to the composition of the primordial solar nebula, from which the entire solar system was formed. The pull of Jupiter's gravity has helped shape the fate of our system. It may have violently hurled Neptune and Uranus outward. The temperature in the clouds of Jupiter is about -145 degrees Celsius. The temperature near the planet's center is much hotter. It may be about 24,000 degrees Celsius, and it is hotter than the surface of the Sun. As Jupiter spins, the swirling liquid metal ocean creates the strongest magnetic field in the solar system. At the tops of the clouds, Jupiter's magnetic field is 20 times stronger than the magnetic field on Earth. Last but not least, researchers have found no evidence for life on Jupiter. The Great Red Spot is the most noticeable feature on Jupiter's surface, which has raged for over a century since the first confirmed sighting in 1831. Therefore, a couple of spacecraft were sent to Jupiter to enhance the study of GRS. The image shown is the picture of Jupiter's Great Red Spot, which captured by Juno spacecraft. It is predicted that Jupiter's upper atmosphere composition caused the reddish color of Great Red Spot. This giant oval of reddish-colored clouds race counterclockwise around the oval perimeter with wind speeds greater than any storm on Earth. Measuring about 10,000 miles in width, as of 3rd of April 2017, the Great Red Spot is 1.3 times as wide as Earth by Juno, while its roots go from 50 to 100 times deeper than Earth's ocean and are warmer at the base, which detected by Juno's microwave radiometer. However, in 2017, the size of Jupiter's Great Red Spot has diminished in width by 1/3 and height by 1/8 as compared to the data collected from Voyager 1 and Voyager 2 in 1979. During that time, the spot was about twice times of Earth's diameter. According to the evolution of Great Red Spot from 1995 to 2015, scientists have noticed that it has been getting smaller and rounder in area over time. Because of this, many expected to see the wind speeds inside the Great Red Spot increase as the storm was shrinking, like the ice skater who spins faster as she pulls her arms, decreasing her base. However, the fact goes against the expectation. The Great Red Spot's spinning speed doesn't increase while its color is deepening. The failure has led to a more explanatory conclusion that the storm appears to be forced to stretch up instead of spinning faster, like clay being shaped on a potter's wheel. The smaller he makes the base, the taller the vessel will go. The Great Red Spot is actually growing taller. Other than that, the gradual deepening of the spot is possible due to the chemicals which color the storm are being carried higher into the atmosphere as the spot stretches up. At higher altitudes, the chemicals would be subjected to more UV radiation and would take on a deeper color. The discussion on Jupiter's Great Red Spot was officially disclosed by NASA.
August 5, 2011, NASA launched a spacecraft named Juno aboard an Atlas V551 rocket with a mission to learn how Jupiter was formed and how it has evolved for improving our understanding of the solar system beginnings by revealing the origin and evolution of Jupiter. Once Juno separates from the last rocket stage, its solar arrays unfold, allowing it to capture the sunlight that gives it life. Over the next few weeks, Juno's other components and scientific instruments are turned on and tested to ensure they are working properly.
Juno is studying the gas giant's gravitational and magnetic fields, vast magnetosphere, intense aurora, and exploring the swirling clouds that form Jupiter's colorful trademark atmosphere. The spacecraft will also reveal what Jupiter is made of and how much of it is water. To make sure Juno can stay around Jupiter, it uses a spinning solar-powered spacecraft in a highly elliptical polar orbit that avoids most of Jupiter's high radiation regions. Juno was carefully designed to meet the tough challenges in flying a mission to Jupiter: weak sunlight, extreme temperatures, and deadly radiation. The spacecraft is covered in thermal blankets to protect it from extreme environment of space. All of the most sensitive electronics are placed inside an armor valve to shield them from Jupiter's deadly radiation. After traveling in space for 2 years, Juno swings by Earth in October 2013, and it will use Earth's gravity to help propel itself toward Jupiter, a maneuver sometimes called a gravitational slingshot. When Juno arrives Jupiter at July 2016, it will perform a delicate maneuver to slow down and enter Jupiter's orbit. Once Jupiter's gravity captures Juno, the spacecraft begins its carefully designed orbit that allows it to closely examine the planet while avoiding its harmful radiation. On 29 October 2018, Juno spacecraft catches changing cloud formations across Jupiter's southern hemisphere. A cloud in the shape of a dolphin appears to be swimming through the cloud bands along the south-south temperate belt. Due to a concern about warp on the spacecraft fuel system, Juno is in 53-day orbits rather than 14-day orbits as initially planned. To provide sufficient time for Juno to achieve its primary objective, NASA has approved a replan to Juno-sized operation until July 2021. In 1979, the Voyager 2 spacecraft discovered Jupiter has its own ring system. NASA was surprised when they saw tiny dark particles circling around Jupiter. Unlike Saturn's rings, Jupiter's rings are relatively dimmer and dusty because they are older and surrounded by a thick layer of dust. The data collected by Galileo spacecraft explained the formation of the rings. It was said that Jupiter's small innermost moon was hit by the interplanetary meteorites, and dust particles were released during the event. As time flies, the ring will form from the dust. It can only be seen when reflected by the sun's light.